Good wishes to all of you. Fundamentals of Physical Geography textbook for class 11, 12th chapter, World Climate and Climate Change. The world climate can be studied by organizing information and data on climate and synthesizing them in smaller units for easy understanding. Description and analysis. Three broad approaches have been adopted for classifying climate. They are empirical, genetic, and applied. Empirical classification is based on observed data, particularly on temperature and precipitation. Genetic classifications attempts to organize climates according to their causes. Applied classification is for specific purpose. Koypen's scheme of classification of climate. The most widely used classification of climate is the empirical climate classification scheme developed by V. Koypen. Koypen identified a close relationship between the distribution of vegetation and climate. He selected certain values of temperature and precipitation and related them to the distribution of vegetation and used these values for classifying the climates. It is an empirical classification based on mean annual and mean monthly temperature and precipitation data. He introduced the use of capital and small letters to designate climatic groups and types. Although developed in 1918 and modified over a period of time, Köppen's scheme is still popular and in use. Köppen recognized five major climatic groups. Four of them are based on temperature and one on precipitation. Table 12.1 lists the climate groups and their characteristics according to Köppen. The capital letters A, C, D, and E delineate humid climates and B dry climates. The climatic groups are subdivided into types designated by small letters based on seasonality of precipitation and temperature characteristics. The seasons of dryness are indicated by the smaller letters small f, small n, small w, and small s, where f corresponds to no dry seasons. Table 12.1 Climatic groups according to Köppen. Group characteristics. A. Tropical. Average temperature of the coldest month in 18 degrees centigrade or higher. B. Dry climates. Potential evaporation exceeds precipitation. C. Warm temperature. The average temperature of the coldest month of the mid latitude climates years is higher than minus 3 degrees Celsius but below 18 degrees Celsius. D. Cold snow forest climates. The average temperature of the coldest months is minus 3 degrees or below. E. Cold climates. Average temperature for all months is below 10 degrees Celsius. H. Highland cold due to elevation. M. Monsoon climate. W. Winter dry seasons and S. Summer dry seasons. The smaller letters A, B, C, and D refer to the degree of severity of temperature. The B. Dry climates are subdivided using the capital letters S for steppe or semi-arid and W for deserts. The climatic types are listed in Table 12.2. The distribution of climatic groups and types is shown in Table 12.1. Take a look at Table 12.2 Climatic Types according to Köppen. Group, type, letter code, characteristics. A. Tropical humid climate type. Tropical wet AF. Characteristics: no dry seasons. Tropical monsoon. Capital A, small m. Monsoonal short dry season. Tropical wet and dry. Capital A, small w. Winter dry season. B. Dry climate. Subtropical steppe. Capital B, capital S, small h. Low latitude semi-arid or dry. Subtropical desert. Capital B, capital W, small h. Low latitude arid or dry. Mid latitude steppe. Capital B, capital S, small k. Mid latitude semi-arid or dry. Mid latitude desert. Capital B, capital W, small k. Mid latitude arid or dry. C. Warm temperate mid latitude climates. Humid subtropical. Capital C, small f, small a. No dry season, warm summer. Mediterranean. Capital C, small s. Dry, hot summer. Marine west coast, capital C, small f, small b, no dry season. Warm and cool summer. D. Cold snow, forest climates. Humid continental, capital D, small f, no dry season. Severe winter. Subarctic, capital D, small w, winter dry and very severe. E. Cold climates, tundra, capital E, capital T, no true summer. Polar ice cap, capital E, capital F, perennial ice. H. Highland, highland, capital H, highland with snow cover. Group A, tropical humid climates. Tropical humid climates exist between Tropic of Cancer and Tropic of Capricorn. The sun being overheated throughout the year and the presence of intertropical convergence zone ITCZ make the climate hot and humid. Annual range of temperature is very low and annual rainfall is high. The tropical group is divided into three types, namely capital A small f, tropical wet climate, capital A small m, tropical monsoon climate, capital A small w, tropical wet and dry climate. Tropical wet climate, capital A small f. Tropical wet climate is found near the equator. The major areas are the Amazon basin in South America, western equatorial Africa and the islands of East Indies. Significant amount of rainfall occurs in every month of the year as thunder showers in the afternoon. The temperature is uniformly high and the annual range of temperature is negligible. The maximum temperature on any day is around 30 degrees Celsius while the minimum temperature is around 20 degrees Celsius. Tropical evergreen forests with dense canopy cover and large biodiversity are found in this climate. Tropical monsoon climate, capital A small m. Tropical monsoon climate, capital A small m is found over the Indian subcontinent, northeastern part of South America and northern Australia. Heavy rainfall occurs mostly in summer, winter is dry. The detailed climatic account of this climate type is given in the book on India, Physical Environment. Tropical wet and dry climate, capital A small w. Tropical wet and dry climate occurs north and south of capital A small f type climate regions. It borders with a dry climate on the western part of the continent and capital C small f or capital C small w on the eastern part. Extensive capital A small w climate is found to the north and south of the Amazon forest in Brazil and adjoining parts of Bolivia and Paraguay in South America. Sudan and south of Central Africa. The annual rainfall in this climate is considerably less than that in capital A small f and capital A small m climate types and is variable also. The wet season is shorter and the dry season is longer with the drought being more severe. Temperature is high throughout the year and diurnal ranges of temperature are the greatest in the dry seasons. Deciduous Deciduous forest and tree shredded grassland occur in this climate. Dry climate, capital B. Dry climates are characterized by very low rainfall that is not advocate for the growth of plants. These climates cover a very large area of the planet extending over large latitudes from 15 degrees to 60 degrees north and south of the equator. At low latitudes from 15 degrees to 30 degrees, they occur in the area of subtropical high where subsidence and inversion of temperature do not produce rainfall. On the western margin of the continents adjoining the cold current, particularly over the west coast of South America, they extend more equatorwards and occur on the coastline. In middle latitudes from 35 degrees to 60 degrees north and south of equator, they are confined to the interior of continents where maritime humid winds do not reach and to areas often surrounded by mountains. Dry climates are divided into steppe or semi-arid climates, capital B, capital S, and desert climate capital B, capital W. They are further subdivided as subtropical steppe, capital B, capital S, small h, and subtropical desert capital B, capital W, small h at latitudes from 15 degrees to 35 degrees and mid latitude steppe, capital B, capital S, small k, and mid latitude desert capital B, capital W, small k at latitudes between 35 degrees to 60 degrees. Subtropical steppe, capital B, capital S, small h, and subtropical desert capital B, capital W, small h climates. Subtropical steppe, capital B, capital S, small h, and subtropical desert capital B, capital W, small h have common precipitation and temperature characteristics located in the transition zone between humid and dry climates. Subtropical steppe receives slightly more rainfall than the desert, adequate enough for the growth of sparse grassland. The rainfall in both the climates is highly variable. The variability in the rainfall affects the life in the steppe much more than in the desert, more often causing famine. Rain occurs in short, intense thunder showers in desert and is ineffective in building soil moisture. Fog is common in coastal deserts bordering cold currents. Maximum temperature in the summer is very high. The highest shade temperature of 58 degrees Celsius was recorded at Al Ajijah, Libya on 13 September 1922. The annual and diurnal ranges of temperature are also high. Warm temperate mid-latitudes climates C. Warm temperature mid-latitude climates extend from 30 degrees to 50 degrees of latitude mainly on the eastern and western margins of continents. These climates generally have warm summers with mild winters. They are grouped into four types: humid subtropical, that is dry in winter and hot in summer, C small w small a; Mediterranean, C small s, humid subtropical, that is no dry season and mild winter, C capital small f small a, marine west coast climate, C small f small b; humid subtropical climate, C small w small a. Humid subtropical climate occurs poleward of Tropic of Cancer and Capricorn, mainly in North Indian plains and South China interior plains. The climate is similar to a small w climate except that the temperature in winter is warm. Mediterranean climate, C small s. As the name suggests, Mediterranean climate occurs around Mediterranean Sea along the west coast of continents in subtropical altitudes between 30 degrees to 40 degrees latitudes. Example: Central California, Central Chile, along the coast in southeastern and southwestern Australia. These areas come under the influence of subtropical high in summer and westerly wind in winter. Hence, the climate is characterized by hot, dry summer and mild, rainy winter. Monthly average temperature in summer is around 25 degrees Celsius and in winter below 10 degrees Celsius. The annual precipitation ranges between 35 to 90 centimeters. Humid subtropical, C small f small a climate. Humid subtropical climate lies on the eastern parts of the continent in subtropical latitudes. In this region, the air masses are generally unstable and cause rainfall throughout the year. They occur in eastern United States of America, southern and eastern China, southern Japan, northeastern Argentina, coastal South Africa and eastern coast of Australia. The annual averages of precipitation vary from 75 to 150 centimeters. Thunderstorms in summer and frontal precipitation in winter are common. Mean monthly temperature in summer is around 27 degrees Celsius and in winter it varies from 5 degrees to 12 degrees Celsius. The daily range of temperature is small. Marine west coast climate, C small f small b. Marine west coast climate is located poleward from the Mediterranean climate on the west coast of the continents. The main areas are northwestern Europe, west coast of North America, north of California, southern Chile, southeastern Australia and New Zealand. Due to marine influence, the temperature is moderate and in winter it is warmer than for its latitude. The mean temperature in summer months ranges from 15 degrees to 20 degrees Celsius and in winter 4 degrees to 10 degrees Celsius. The annual and daily ranges of temperature are small. Precipitation occurs throughout the year. Precipitation varies greatly from 50 to 20 to 50 centimeters. Cold snow forest climates. D. Cold snow forest climates occur in the large continental area in the northern hemisphere between 40 degrees to 70 degrees north latitudes in Europe, Asia and North America. Cold snow forest climates are divided into two types: D small f cold climate with a humid winter, D double small w cold climate with dry winter. The severity of winter is more pronounced in higher latitudes. Cold climate with humid winters. D small f. Cold climate with humid winter occurs poleward of marine west coast climate and mid latitude steppe. The winters are cold and snowy. The frost free season is short. The annual ranges of temperature are large. The weather changes are abrupt and short term. Poleward, the winters are more severe. Cold climate with dry winters. D small w. Cold climate with a dry winter occurs mainly over northeastern Asia. The development of pronounced winter anti-cyclone and its weakening in summer sets in monsoon like a reversal of wind in this region. Poleward summer temperatures are lower and winter temperatures are extremely low with many locations experiencing below freezing point temperatures for up to 7 months in a year. Precipitation occurs in summer. The annual precipitation is low from 12 to 15 centimeters. Polar climates. E. Polar climates exist poleward beyond 70 degrees latitude. Polar climates consist of two types: tundra ET, ice cap EF. Tundra climate ET. The tundra climate ET is so called after the types of vegetation like low growing mosses, lichens and flowering plants. This is the region of permafrost where the subsoil is permanently frozen. The short growing season and water logging support only low growing plants during summer. The tundra regions have very long duration of daylight. Ice cap climate EF. The ice cap climate EF occurs over interior Greenland and Antarctica. Even in summer, the temperature is below freezing point. This area receives very little precipitation. The snow and ice get accumulated and the mountaining pressure causes the deformation of the ice sheets and they break. They move as icebergs that float in the Arctic and Antarctica waters. Plateau Station, Antarctica, 79 degrees south, portray this climate. Highland climate H. Highland climates are governed by topography in high mountains. Large changes in mean temperature occur over short distances. Precipitation types of intensity also vary spatially across highlands. There is vertical zonation of layering of climatic types with elevation in the mountain environment. Climate change. The earlier chapters on climate summarized our understanding of climate as it prevails now. The type of climate we experience now might be prevailing over the last 10,000 years with minor and occasionally wide fluctuations. The planet Earth has witnessed many variations in climate since the beginning. Geological records show alternation of glacial and interglacial periods. The geomorphological features, especially in high altitudes and high latitudes, exhibit traces of advances and retreats of glaciers. The sediment deposits in glacial lakes also reveal the occurrence of warm and cold periods. The ring in the trees provide clues about wet and dry periods. Historical records describe the vagaries in climate. All these evidences indicate that change in climate is a natural and continuous process. India also witnessed alternate wet and dry periods. Archaeological findings show that the Rajasthan desert experienced wet and cool climate around 8000 BC. The period 3000 to 1700 BC had higher rainfall. From about 2000 to 1700 BC, this region was the center of the Harappan civilization. Dry conditions accentuated since then. In the geological past, the earth was warmed some 500 to 300 million years ago through the Cambrian, Ordovician, and Silurian periods. During the Pleistocene epoch, glacial and interglacial periods occurred. The last major peak glacial period was about 18,000 years ago. The present interglacial period started 10,000 years ago. Climate in the recent past. Variability in climate occurs all the time. The 90s decade of the last century witnessed extreme weather events. The 1990s recorded the warmest temperature of the century and some of the worst floods around the world. The worst devastating drought in the Sahel region south of the Sahara Desert. From 1967 to 1977 is one such variability. During the 1930s, severe drought occurred in southwestern Great Plains of the United States, described as the Dust Bowl. Historical records of copy yield or crop failures of floods and migration of people tell about the effects of changing climate. A number of times Europe witnessed warm, wet, cold, and dry periods. The significant episodes were the warm and dry conditions in the 10th and 11th centuries. When the Vikings settled in Greenland, Europe witnessed little ice age from 1550 to about 1815. From about 1885 to 1940, world temperature showed an upward trend. After 1940, the rate of increase in temperature slowed down. Causes of climate change. The causes for climate change are many. They can be grouped into astronomical and terrestrial causes. The astronomical causes are the changes in solar output associated with sunspot activities. Sunspots are dark and cooler patches on the sun which increase and decrease in a cyclical manner. According to some meteorologists, when the number of sunspots increase, cooler and wetter weather and greater storm minus occur. A decrease in sunspot numbers is associated with warm and dried conditions. Yet, these findings are not statistically significant. And another astronomical theory is Melanchovicion Oscillations, which infer cycles in the variations in the Earth's orbital characteristics around the Sun. The wobbling of the Earth and the changes in the Earth's axial tilt, all these alter the amount of insolation received from the Sun, which in turn might have a bearing on the climate. Volcanism is considered as another cause for climate change. Volcanic eruption throws up lots of aerosols into the atmosphere. These aerosols remain in the atmosphere for a considerable period of time, reducing the sun's radiation reaching the Earth's surface. After the recent Pinatubo and El Sion volcanic eruptions, the average temperature of the earth fell to some extent for some years. The most important anthropogenic effect on the climate is the increasing trend in the concentration of greenhouse gases in the atmosphere, which is likely to cause global warming. Global warming. Due to the presence of greenhouse gases, the atmosphere is behaving like a greenhouse. The atmosphere also transmits the incoming solar radiation but absorbs the vast majority of long wave radiation emitted upwards by the Earth's surface. The gases that absorb long wave radiation are called greenhouse gases. The processes that warm the atmosphere are often collectively referred to as the greenhouse effect. The term greenhouse is derived from the analogy to a greenhouse used in cold areas for preserving heat. A greenhouse is made up of glass. The glass, which is transparent to incoming shortwave solar radiation, is opaque to outgoing long-wave radiation. The glass therefore allows in more radiation and prevents the long-wave radiation going outside the glass house, causing the temperature inside the glass house structure warmer than outside. When you enter a car or a bus during summers where windows are closer, you feel more heat than outside. Likewise, during winter, the vehicles with closer doors and windows remain warmer than the temperature outside. This is another example of the greenhouse effect. Greenhouse gases GHGs. The primary GHGs of concern today are carbon dioxide (CO2), chlorofluorocarbons (CFCs), methane (CH4), nitrous oxide (N2O), and ozone (O3). Some other gases such as nitric oxide (NO) and carbon monoxide (CO) easily react with GHGs and affect their concentration in the atmosphere. The effectiveness of any given GHG molecule will depend on the magnitude of the increase in its concentration, its lifetime in the atmosphere, and the wavelength of radiation that it absorbs. The chlorofluorocarbons (CFCs) are highly effective. Ozone, which absorbs ultraviolet radiation in the stratosphere, is very effective in absorbing terrestrial radiation when it is present in the lower troposphere. Another important point to be noted is that the more time the GHG molecule remains in the atmosphere, the longer it will take for its atmospheric system to recover from any change brought about by the latter. The largest concentration of GHGs in the atmosphere is carbon dioxide. The emission of CO2 comes mainly from fossil fuel combustion, oil, gas, and coal. Forests and oceans are the sinks for the carbon dioxide. Forests use CO2 in their growth, so deforestation due to changes in land use also increase the concentration of CO2. The time taken for atmospheric CO2 to adjust to changes in source to sinks is 20 to 50 years. It is rising at about 0.5% annually. Doubling of concentration of CO2 over pre-industrial level is used as an index for estimating the changes in climate in climatic models. Chlorofluorocarbons (CFCs) are products of human activity. Ozone occurs in the stratosphere where ultraviolet rays convert oxygen into ozone. Thus, ultraviolet rays do not reach the Earth's surface. The CFCs, which drift into the stratosphere, destroy the ozone. Large depletion of ozone occurs over Antarctica. The depletion of ozone concentration in the stratosphere is called the ozone hole. This allows the ultraviolet rays to pass through the troposphere. International efforts have been initiated for reducing the emissions of GHGs into the atmosphere. The most important one is the Kyoto Protocol, Kyoto Protocol proclaimed in 1997. This protocol went into effect in 2005, ratified by 141 nations. Kyoto Protocol bounds the 35 industrialized countries to reduce their emissions by the year 2012 to 5% less than the levels prevalent in the year 1990. The increasing trend in the concentration of GHGs in the atmosphere may, in the long run, warm up the earth. Once the global warming sets in, it will be difficult to reverse it. The effect of global warming may not be uniform everywhere. Nevertheless, the adverse effect due to global warming will adversely affect the life supporting system, rise in the sea level due to melting of glaciers and ice caps, and thermal expansion of the sea may inundate large parts of the coastal areas and islands, leading to social problems. This is another cause for serious concern for the world community. Efforts have already been initiated to control the emission of GHGs and to arrest the trend towards global warming. Let us hope the world community responds to this challenge and adopts a lifestyle that leaves behind a livable world for the generations to come. One of the major concerns of the world today is global warming. Let us look at how much the planet has warmed up from the temperature records. Temperature data are available from the middle of the 19th century, mostly for Western Europe. The reference period for this study is 1961 to 90. The temperature anomalies for the earlier and later periods are estimated from the average temperature for the period 1961 to 90. The annual average near surface air temperature of the world is approximately 14 degrees Celsius. The time series show anomalies of annual near surface temperature over land from 1856 to 2000 related to the period 1961 to 90 as normal for the global globe. An increasing trend in temperature was discernible in the 20th century. The greatest warming of the 20th century was during the two periods 1901 to 44 and 1977 to 99. Over each of these two periods, global temperatures rose by about 0.4 degrees Celsius. In between, there was a slight cooling which was more marked in the northern hemisphere. The globally averaged annual mean temperature at the end of the 20th century was about 0.6 degrees Celsius above that recorded at the end of the 19th century. The seven warmest years during the 1856 to 2000 were recorded in the last decade. The year 1998 was the warmest year, probably not only for the 20th century but also for the whole millennium. Take a look at this newspaper images. Greenhouse gases rising alarmingly. Ancient air bubbles buried in Antarctica ice to shed more light on global warming. Ice age cometh. Air pollution biggest kill in Southeast Asia, says WHO. Gangotri is shrinking 23 meters every year. Warming. Arctic clock. Warming Arctic could affect global weather. Write an explanatory note on global warming. Exercises. Multiple choice questions. Which one of the following is suitable for Köppen's A type of climate? High rainfall in all the months. Mean monthly temperature of the coldest month more than freezing point. Mean monthly temperature of all the months more than 18 degrees Celsius. Average temperature for all the months below 10 degrees Celsius. Köppen's system of classification of climates can be termed as applied, systematic, genetic, empirical. Most of the Indian peninsula will be grouped according to Köppen's system under A small f, B S small h, C small f small b, A small m. Which one of the following years is supposed to have recorded the warmest temperature the world over? 1990, 1998, 1885, 1950. Which one of the following groups of four climates represents humid conditions? A, B, C, E, A, C, D, E, B, C, D, E, A, C, D, F. Answer the following questions in about 30 words. Which two climatic variables are used by Köppen for classification of the climate? How is the genetic system of classification different from the empirical one? Which types of climates have very low range of temperature? What type of climatic conditions would prevail if the sunspots increase? Answer the following questions in about 150 words. Make a comparison of the climatic conditions between the A and B types of climate. What type of vegetation would you find in the C and A types of climate? What do you understand by the term greenhouse gases? Make a list of greenhouse gases. Project work. Collect information about Kyoto Declaration related to global climatic changes. Thank you.